So, take your seats, ladies and gentlemen. Right, so now we have, and this is for me a particular honor in that, like, WebRTC for me started a long time ago when a Google M&A man talked to me about a product that we were working on. And he asked me a few questions about it, and I said, one of the answers was, it's written in Java. And he turned away, and that was the end of the conversation. And it turns out that they were hunting for IPR to put into WebRTC, which I hadn't realized at the time. So that was about 8 years ago. And now here we are with WebRTC on, what is it, 2.5 billion endpoints, something like that. And a lot of that is due to the effort that Google have put in on that front. So I'm really delighted, actually, to introduce Huib, who's going to talk about, well, Google Enterprise Grade WebRTC in the browser.
Right, thank you. Thanks for the kind words. Yeah, so my name is Huib Kleinhout. It's a Dutch name, you can't pronounce it unless you're Dutch. I work from Stockholm, and in Stockholm is a large part of the engineers that's in Google that work on the WebRTC stack. They're based. They work on video processing, audio processing, on like the media network components, such as like bandwidth estimation. So I work from day to day with these engineers, and I work also with like Google products that use WebRTC, such as Hangout or Google Duo, and many others. WebRTC kind of started in Sweden, and Sweden, beyond WebRTC, it's also very known for like won the match yesterday from Mexico. My plane was 3 hours delayed yesterday when I arrived, but luckily I got to see the match in the airport, and everyone's happy. It's like I just mentioned. It's like 7 years ago. 7 years ago, there was a formal announcement that from Google they acquired this company called Gibbs. That had built a real-time communication stack, and Google wanted to make this like a community project based on open standards and part of the browsers, which started back then. And since then, basically everyone has been building with this stack and on this stack and creating like what became a leading real-time communication standard. So where are we now in 2018? There's like more than 1,300 WebRTC-based companies. Many of them, they didn't exist before, so there's really an industry has grown. And it's used all over the world. These are like visits to WebRTC.org websites. Of course, a lot comes from Silicon Valley, from the US, but also interestingly from countries like China, where WebRTC is also massive. You have like massive conferences, massive usage. And the problems are quite different. For instance, you have interconnection between different ISPs doesn't really exist. So if you have a call from one ISP to another, you have to like lease capacity to interconnect. Otherwise, you will have no bandwidth available. But WebRTC works. It's flexible enough to also make it work in these special circumstances. There's mobile libraries available on WebRTC.org where everything is compiled because the source code is pretty big. And these have massive downloads, more than almost 10,000 per month last month. And this is just like downloads to developers, which of course distribute them further in their own apps. 6,000 on Cocoa Pods. And in the Chrome browser, we see 1.8 billion weekly minutes, audio-video minutes. That's 300% growth from last year, so it's spectacular growth. Last month we saw data traffic on the data channel double in a month, essentially. So there's like huge growth in the Chrome browser as well. And this is only from the sort of the minutes that we can count in Google. Not everything is trackable. And then of course, like we got WebRTC built in the browsers since a year ago. Safari included WebRTC in their browser a bit over a year ago. Microsoft Edge also includes a form of WebRTC. They're building to improve it, and basically most browsers that are installed have some form of this WebRTC included. In Google, we use WebRTC for tens and tens of projects. The most known one is probably Hangouts Meet, the video conferencing solution that Google has been working on building for many, many years. But also anything like from a Google Home device when you call like someone else on another home device, or when you call within a self-driving car to the service center, all of those things, or I use WebRTC. So it's like really widespread. One reason's migration was that YouTube, which had an like existing stack for many, many years, highly optimized, RTMP based. They switched for YouTube Live to WebRTC, just standard components, Opus, H.264, and as they saw a drastic decrease in buffer rate. So like when you see like buffer and a spinner, which is kind of the most annoying thing when you watch a video, and better quality. So just by switching the stack to WebRTC. So it really worked for a lot of use cases. And it's become a massive industry. So as WebRTC started from like the first like build your own Skype solution where it kind of works and most of the time, that is sort of the easy start, like doing the first 80%. But doing like the last bit is a lot harder. And that's where you get into enterprise grade real-time communication, where it can't just somewhat work, it has to really work all the time. And that's what we've been focusing a lot in the browser. So in Hangouts Meet, the browser is like first grade client, so you get all the features and all the benefits directly in the browser. There's no other native client or a mobile client that offers more features, so everything in the browser has to be at enterprise grade level. And basically what it means is like in the consumer space, if you're like calling someone and the connection breaks up, well then we can like send SMS or like call them with like a old telephone line, or just call them a bit later, and it's kind of fine. But in the business case, it's more complicated. If the connection doesn't work, then you immediately get a lot of frustration, you get a loss of revenue because you can't make a deal, and you get a lot of like frustration amongst the enterprise users. So how is enterprise really different? Well, first of all, in enterprise the meetings are a lot bigger. There's more participants. You typically have a lot of video conferencing rooms with different hardware, from like old Cisco stuff that the company bought and it was very big investment that they want to keep around, to like cheap hardware imported from China and that was cheap on the bulk and like has a lot of problems. So you have to deal with a lot of different hardware setups, and it needs to scale. So everyone in a meeting needs to be able to view media from in whatever situation they are. You need a SFU. You also need to, like clients that have limited connection or limited resources, send them less fidelity in their media, or maybe like be more selective. The second part is that problems sort of scale disproportionately. So if you have sometimes echo, there's always echo, we heard it this morning here. And if there's only a small chance of echo, it's fine in a one-to-one person call if this chance is small. But if you're in like a big conference with a lot of endpoints, then the chance that someone will generate echo, which everyone will hear apart from that single person, is a lot higher. So sort of like small problems like noise and echo, they become a massive problem if you scale up to large meetings just by sheer numbers. And of course the stakes are higher. If you build a consumer product, it's often free, and then it's just like you get what you pay for. But if you actually pay for something and you pay for your enterprise solution, then expectations are a lot higher. So there's a lot less tolerance for failure. And lastly, like a lot of the enterprise solutions, they have more advanced features. They, for instance, like in enterprise, it's common to run presentations, share your screen, do recording, comply with all kinds of regulation, or dial in, interconnect with other voice systems, or offer like over-the-top services such as chat. And you have networks tend to be more complicated. What Meet sees, for instance, is that In enterprise network, there's a lot of TCP usage because administrators, they force all the traffic over TCP where they can have better control and like better inspection. And meaning if you put like a real-time communication on TCP, you will get like long delays and a lot of problems with congestion. So these are like typically a very typical like enterprise network challenges as well. A lot of these challenges in enterprise we aim to address with WebRTC 1.0. And WebRTC 1.0 is like our effort to like finalize the first version after 7-8 years of WebRTC, which has taken a long time, but it's also a very complex tech stack. The key parts of this are the specs. We did like a great presentation earlier about how there's a lot of specs and different implementations of it in compliance way. You have a lot of prefixes where you have to put WebKit this or Google that or Moz that. And make sure that you can test whatever you build so that you can verify that it works every time. And then there's also like a lot of focus on driving down these error rates. So this 1%, 2% to drive them further down because they just need to be very, very low. Why WebRTC 1.0 is very important for the enterprises is with consistent APIs that are the same in all browsers, it's much easier to port your application. You don't need 1,800 lines of like compatibility code for 400 lines of application code. All the APIs in WebRTC 1.0 also offer all these scalability features to in different networks and different clients. And yeah, of course, the failure rates that need to go down. On spec and compliance side, there's a lot of specs. I'm sure many of you are known at least a bunch of those that are covered by WebRTC. WebRTC is this huge stack of technologies glued and stacked together to make a connection because it's just very hard. And there's a lot of existing specifications and specifications that were modified. From the two main areas are from WebRTC or from W3C, which are like the JavaScript APIs, and then they have all the protocols. The network protocols are governed by IETF. In addition to that, there's like standards for video coding and audio coding, like WebM and AO Media for new AV1. Most of these specs are sort of finalized or being finalized. So RC means is basically the end station for IETF specs, and candidate recommendation is like close to the end station for W3C specs. So they were pretty good. Recently in the working group, it was decided to move simulcast and scalable video coding out into an extension spec. There's still work to be done, but other than that, like most of these things are in bug fixing mode. And a lot happened there. We saw earlier this beautiful piece of SDP that you have to pass around in across the clients using your own signaling. This is very painful, and Microsoft, when they introduced their first version of WebRTC, it was called RTC, it aimed to address that with better object APIs. In the end, that was a too drastic change for the path that WebRTC was already on, so it was kind of like merged together into WebRTC 1.0, where like some of the IDs and some of the APIs and ORTC were merged in WebRTC, and the rest were just like put on hold for them. And this spec is what everyone implements now as well. Also Microsoft. The different browsers, yeah. So in Chrome, we've been quite busy the last year on actually being more spec compliant. So Chrome was basically the first browser that implemented WebRTC, and also still has a bit outdated version of the spec implemented. But we work now hard on that, on catching up and making sure that everything in Chrome is spec compliant, and it will work the same across browsers. Here are some of the like key APIs that have been added in the recent Chrome versions. So Chrome is now at Chrome 67, that's stable. We worked on like RTP media interfaces, which will be needed for Unified Plan, the standardized SDP across all the browsers. And Unified Plan SDP is something we want to enable in Chrome 72, which will be early 2019. And this will be like a major step towards like complete compliance across browsers. As the WebRTC stack is like built up, there's like for all the APIs, whether they're mobile APIs or the web APIs, there's underlying C++ APIs. So any of those APIs are basically the same, and all the updates are like mirrored in across the C++ and higher level APIs. If you look at browser support, Chrome, of course, always builds from up-to-date WebRTC, like it's fully integrated, and the JavaScript layer follows closely the C++ layer. For Firefox are also quite closely tracking. They have a custom JavaScript layer for instance, for the SDP parsing and like a lot of things that happen you call directly from JavaScript. But they're quite up to date as well, and we work with the Mozilla team to make sure that they can catch up quickly and that they're code-wise aligned. Similar for Safari, they have fewer releases, only 2 per year. The Safari main stable browser, so there's not so many updates, and they're trailing a bit longer behind, but they're also quite more closely following the spec because they only recently added it. Edge has been the special case because they had like their own RTC standard and implementation, but there's really good signals that they actually want to also be conformant with WebRTC 1.0 spec. Then for enterprise, you need scalability. It needs to work from very low bit rates to very high bit rates. If you're in a meeting with 100 people, you can't just send like 1 megabit per each participant to each participant. Like sending 100 megabits to a mobile phone won't really work. So yeah, we need scalability features there. Something that's been built into the spec and sort of half implemented, but will be more consistently implemented in the browser is simulcast, where you can get different streams at different qualities or different resolutions, different frame rates for video. So you can send like the lowest quality video, for instance, to a mobile phone. Some of the APIs that have been added is contributing sources, where you can have like many audio sources being virtualized over a real audio track, and this helps you to like deal if you have many participants and knowing which participants are talking. So this is also like a scalability feature that's built into the spec. And then in Chrome we're implementing encoding parameters where you can, for different video streams, can set things like the max bit rate and frame rate to control like what kind of rate the streams, how you configure the streams. One interesting development is VP9, where Google has been working on for many years, and now it's become, since Chrome releases, it's standard available in WebRTC. You can set it up without special flags. In general, it provides like 35% better visual quality, and you can send HD at 700 kilobit instead of 1200. In this graph, you can sort of see the white areas where you are in HD, and this is like uplink and downlink, and you can see that the white area is a lot lower bit rates compared to the VP8. On testing front, a lot happened as well. For all the web browser tests, there's something called a web platform test. These are sort of industry shared tests for web technology, where you can test things like HTML, CSS, and all kinds of standards automatically. And most browser vendors, they run these tests for each commit that you do in the source code of a browser. So when you do a commit, you get like it runs all the tests for all the specs, and if one of them starts failing, then you can't merge that commit. So this is very powerful to make sure that like the browsers remain spec compliant. And over the last year, we added a lot of these tests for WebRTC, and WebRTC is also part in a dashboard that you can see. It's supposed to be green. It's very red still. There's different reasons for why it's red. One of the reasons is because most browsers are not very spec compliant yet in WebRTC, but also some of the automation hasn't been in place. So WebRTC typically have to approve the camera and microphone access, which this test framework could not do automatically. Click that dialog. So then a lot of test case fail. So this is getting into place, so we can actually run these tests continuously and can compare the different browsers. But then the web platform tests are really focused on testing JavaScript to browser and then like one server interaction. So like the typical web stack. But of course WebRTC is special. We don't have just one client, we have many clients and they also talk with each other. And the talking with each other happens with different protocols than like in a typical scenario. We don't have HTTP and TLS, but not many other protocols. But for WebRTC, you have a lot of other different protocols, TUN, STERN, SRTP, SCTP, RTP, for moving data around. And there hasn't been really a test framework for that before. So we worked with one of the participants here, Cosmo Media, represented by Alex, who had a talk earlier at the conference. We worked to develop Kite. So the team developed a new test system which can basically run any browser in any kind of environment in a Selenium grid and run a bunch of interoperability tests against each other. And this is very powerful because it allows us to not only test if browsers can actually talk with each other, but it also allows third-party developers to test their own application. So you can make an application, a web application, and test it in the different browsers, different environments, and make sure it keeps working for every browser update and every update you do in your app. And this is a fully open source project, and we're very eager to see more people picking up and trying it out and hearing feedback about it. Yeah, so reliability is perhaps the most important part of enterprise-grade real-time communication. And there, like getting audio or video from one point to another point, and it's also very complicated. You have a lot of components. You have WebRTC implementations, operating systems, you have like the transport over the cloud, and there's a lot of problems things that can go wrong. Ironically, like one of the most common failures for people not hearing each other is that they're muted. So people often mute in a conference because, yeah, if someone else is talking and they don't want to hear the kid in the background like crying, then they mute themselves. They start talking and nobody hears them. They get annoyed. And this is like a common failure. Of course, this is not something we can fix in the browser, but ironically that's one of the biggest problems. There are a lot of problems that you can diagnose in the browser, and that we could actually work on. For instance, like many audio devices, they are built with device drivers that are very shaky, they're very minimalistic implemented, no error handling. If anything goes wrong, they just bork and fail. And the only way to deal with it is to restart the driver in the operating system, or they just crashed. This is a real problem. This is like a few percent of the cases when you try to get media, this happens. And there's also a lot of other issues you can get with like where the network gets, if you move from one Wi-Fi access point to the other and the network stops working. Over the last year, we added a lot of APIs and improved APIs to diagnose these kind of cases. So there's more APIs to get device-specific information, so you know which devices the user is using, whether it's a USB headset or whether it's just the speaker and microphone on the laptop. There's events implemented where you can see if the device driver crashes, it will emit an event that the media stream stopped or that is muted for some reason. and you have a lot of metrics in get stats that allow you to diagnose if actually something is happening. For instance, with the audio energy, you can see if there's actually some kind of volume coming from the microphone. Perhaps one of the most impactful fixes we've done in Chrome was a situation on macOS where audio didn't work in a large number of cases, up to 8% of all the calls. And this was a problem for many years. We couldn't really figure out what was going on, but in the end we found out that it was like a macOS bug that happened in a certain race condition when you put the computer to sleep. Then we implemented the workaround for it in Chrome 63, and that just basically solved the problem. So it went from 8% to almost nothing. We're also working a lot on audio processing. So echo is pretty hard, as we heard today. It's a hard problem. The main challenge with echo is that you have to, from the input signal that you get, you have to subtract exactly the right output signal to match it. And if you're just a little bit off in time or in volume, you'll hear echo. And this comes like at needs to come at subsample precision. So if you're one audio sample off, then you will already hear echo. So it's super accurate and super sensitive. We worked on a new echo canceller, AC3, that's built in Chrome and WebRTC, and we're gradually landing this, working with built-in ACs and Windows and Mac to just eliminate this problem as much as we can. Also, like on screen share, quite common use case in enterprise situations. Earlier there was like in the worst cases, like the 99 percentile, so like the slowest update case, if you change the slide on the screen like this, it could take up to like 20 seconds just because the network is congested and we send too much data. And with like better pacing and detecting these congestions, the worst case actually was reduced to just a few seconds, and in the 99 percentile. And this is at the frame rate of 5 frames per second, so 200 milliseconds per frame. Lastly, we're in Chrome 68, we're landing the Chrome audio capture process, which isolates all the audio processing in its own process. There's two reasons for it. One is sort of to bring all the audio processing, like echo, which is very time sensitive, closer to the device drivers, to where the hardware is. Secondly, also to isolate any kind of problems like crashes and freezes from the rest of WebRTC, so we can just restart the process. And what you'll see is basically like if you're having a call and the device driver crashes, you'll get just a short interruption of half a second where you restart the audio process and it will just continue to work. Previously, it will crash the whole Chrome browser. This process separation already happened for Chrome video capture. So the camera capture, we also were a lot of crashes initially coming from Mac, where like the video camera would crash and it would take down the whole browser. Now it just the framework will just go black and you can reload the page and it works again. So yeah, over the last milestones, we had tons of these fixes from glitches to microphone failures to echo, also enterprise-specific network problems, like if you run in a virtualized environment, so run the browser in remote desktop and try to have a call, or in a Citrix environment. This wouldn't work, you would get a lot of jitter, and basically by allocating device buffers a bit differently and more dynamically, we could avoid these problems. And these are very enterprise specific, like no end user runs their browser in a Citrix environment at home. So yeah, in Chrome 70 we'll get like a fix to automatically detect audio driver hangs, which is a very common problem as well. On screen capture, so sharing a screen, we just announced that we're going to implement Get Display Media, which is a standard-based way to capture the screen and send it over a peer connection. This has already been implemented just earlier by Edge in March this year. Firefox has something like similar. It's an old version of the spec, and they'll probably update it as well. And Safari is like developing this. They have it in the WebKit source tree and functionality, but it's disabled by default. There's no user interface yet. But this will be like also like a standard way of doing it, and allow you to remove some of this special compatibility library that you need to use WebRTC across the browsers, different browsers. So yeah, with WebRTC 1.0, we're now finally getting to like consistent APIs across browsers after like 7-8 years. Finally, things are getting together. It has transformed from like a consumer-grade product and APIs to enterprise-grade. So like the highest, almost highest level of requirements that you can get. And it contains tons of features for scalability and enterprise networks. Both in the specs and different browsers, but also through different policies that Chrome has for working in enterprise buildings, in enterprise environments. Yeah, we have a lot of testing frameworks that we're building and continue to build on to make sure you can test stuff and make sure it keeps working. And best of all, it's fully open source. So that's it. Yeah, sure, go ahead.
So, yeah, questions?
Thanks, Tim. Hey, I just had a quick question. I haven't been keep on top of the spec lists or anything like that lately. What was the impetus for the change from an extensionless screen share, the ability to do screen capture for screen sharing? How did they get around the security concerns that they had with regards to, because I think there were security reasons why they decided to go with an extension-based approach. What changed, and why do they think they can safely get away without doing that?
Yeah, correct. So the reason why this was an extension in Chrome and it was a whitelist in Firefox was for like privacy and security reasons. Meaning like if you can accidentally share your screen, that's a huge privacy issue. And of course, people get tricked to do all kinds of things in their browser. So it was a really serious concern. Chrome implemented extension as an extension, so as a safeguard, and Firefox had a whitelist. Firefox abandoned the whitelist because it doesn't scale, of course. They had to keep adding stuff to the URLs to the whitelist. And they introduced a more scary UI that like allows you to be more consciously accepted. In Chrome, we also plan to go that route. After seeing the amount of abuse, that is quite reasonable. Like there's no safe, and that we can solve this in UI. We also decided to go that way. One additional difference from when this was originally introduced is that Chrome has like a safe browsing feature, which allows you to blacklists URLs that are known to be fraudulent or spread virus and malware, and we can use that also as a measure to mitigate any kind of attacks. So if a site would try to trick people in sharing their screen, we could use that feature to block that site. So that's basically the transition why it's been standardized now. Still, it remains tricky. The reason why Apple has not implemented this is no doubt because of the security problems.
Questions?
So the echo cancellation piece that you talked about being moved into all the audio capture being moved into a single process, does that aggregate the echo cancellation across multiple audio sources playing at the same time, including outside of the Chrome browser?
So for echo cancellation to work, you have to have the output signal as a reference. So you need to know what's being played out at the speaker, and in addition to what recording, know what's being recorded on the microphone. So you need to have a reference signal so you can subtract that. So that is a prerequisite if you have multiple sources. If you don't get that, it becomes very, very hard, which was what happened with the laptop probably this morning. Also, with echo cancellation, the echo path needs to be relatively consistent, meaning that if you have echo coming from one side of the room and from another side of the room, and those two are, both of them are strong and very different, it becomes very complicated. You can get like echo failures which introduce echo, but generally, like if the echo canceller doesn't work, it will duck, meaning that it will realize that it can't cancel the echo, and will just suppress everything, like it will sound very muffled. So yeah, this echo cancellation is super complex, and you will need to know at least the reference signal to make it work, and it could work for multiple sources, but depending on the setup, it might still fail.
In the beginning, you said that you recently noticed that traffic over data channels grew.
Mm.
Was that a sudden change, and do you know what caused it?
We don't know what caused it. There's been fluctuations before, like we saw like big bumps and then like declines again. So obviously there's big parties testing or like doing stuff with data channels. We know there's like different companies like Peer 5, Akamai are using data channels for like distributing data, and it could be one of those. So this is like the data channel is kind of like pretty separate actually from WebRTC sending audio, video, but a very important use case because there's many use cases where you want to like send data or real time at like a real time pace to another client.
Do you actually, quick question on that? Do you have a percentage of that? Can you give us a scale? I mean, you told us how much it had gone up, but like, can you give us a measure of?
So I mean, now we saw this bump of like 2x in a month. In general, like WebRTC traffic, as you see it in the Chrome browser, it grows a few times, like 3 times per year or something, like 3x per year, generally over the past years. So it's like pretty rapid growth.
So that's definitely a spike then.
Yeah.
So just a question, which are your hopes for WebRTC next generation? I mean, lack of SDP, encodings, encoders, RTP params, or which are your thoughts about the future?
I think still right now and probably still for the upcoming year, it's like we need to reach stability, like and consistent APIs and stability. This is super important to build good services upon. And like as mentioned before, real-time communication is not anymore. It's really assumed to work. Also, I think what we'll see is like more lower-level APIs. So there's been and a lot of new technologies in the browser, like WebAssembly, like all that allow you to do like stuff really at a low level, at high performance, and like we would like to hook that up in like with real-time communication. So you could, for instance, do like processing in a browser, run your own algorithms like audio processing or video processing right in the browser without like relying on features that are part of the stack.
Any more questions? No? Got another minute? You can, quick question? No? Okay, cool. So, ik wil je hartelijk danken voor de
Thank you.
verhaal. And also, if you want to, I'm sure you'll be here at lunch and catch them then. Now, we have, I think, a 10-minute break now, and then we come back with Sergio is going to talk about how you select your SFU. So, thank you very much.
Yeah. Thanks, Jeff.